Sample problem on composite functions. This one's asking you to find g of f of x, given that g is this function and f is this function. If you were to take g of f of x, I would simply write down g of x, but every time there's an x, I would just put a big parentheses there for it and still keep the rest of the function intact. So wherever I see the x in this function here is represented by these parentheses. Now I'm going to plug in the other function because g is really just taking g of this object, and here's this object. So I'm going to now plug this in here. I'm going to go 4x to the minus fifth. If you can read my writing there. Okay, now how do I simplify that? Well, just like I would take 2x quantity squared, right? I square the number and I square the exponent, or square the variable as well. So I take the number here and I'm going to go 4 to the 3/4 times x to the minus 5 times 3/4, because that's what I do when one exponent is taken to another power like that. And so I'm going to now get this situation here. Get rid of this here real quick. I'm going to get this situation here where I'm just going to take 4 to the 3/4, which turns out to be 2.83. Okay, x to the minus 15/4. That's what it would look like. Okay, I think other books might write this differently. They might write this as 4 cubed to the 4th root. Okay, and if you do that, you can get some other variation of 2. Okay, but I didn't do it that way. I did it just punch into my calculator and I got 2.83. So whatever you see the answer, if you see the answer in the back of a book or something and their answer looks different, like it's 2 to a certain power, do it in your calculator. Whatever is in that power, just do it in your calculator and see that you'll get the same answer. Okay, now they ask us about domain. This is the final answer, by the way. G of f of x is this answer here. But what is our domain? Let's think about what this looks like. Here's a constant, 2.83. Okay, and now we have x to the minus 15/4. Oh, that's really 1 over x to the 15th, right? If it's a negative exponent, I bring it down, and the 1/4 fraction means it's a 4th root. Okay, I hope you can see that this is the same as this. Okay, 4th root of 1 over x to the 15th. Now, this is an odd number. If this is an even number, maybe it wouldn't matter, but it's an odd number. Therefore, if x was negative, suppose x was less than 0. Plug in a -1, for instance. -1 to the 15th gives me -1. 1 divided by -1 leaves me with a -1. If I get a -1 under an even numbered root, like squared or 4th or 6th, I have a problem. I can't possibly find a number that when I multiply it by itself 4 times, I'm going to get a negative. So this can't happen. Therefore, my domain is all x's such that x is greater than or equal to 0. Your book might say all real positive numbers. Okay, but either way, can't write very well here on this screen, but anyway, domain is all real positive numbers. I would say all x such that x is greater than or equal to 0. It does work for 0. Actually, no, not less than. It's got to be greater than 0. So I plug a 0 in, then get a 0 in the bottom. So leave out 0. It's got to be all x greater than 0 or all real numbers. Okay, hope that helps. There you go.